Okay, let's dive right into this explainer. Today, we're going to learn exactly how to take those basic, everyday AI models and completely upgrade them into autonomous, context-aware super teams. You know, if you've ever felt completely limited by a standard chatbot that just answers prompts in a vacuum, well, you are definitely in the right place. We're going to open up the hood of Crew AI and see step by step how to build a truly advanced AI crew, one packed with a memory, real-world tools, and some pretty complex organizational structures.
So here is our roadmap for today. We'll start with the agentic AI landscape, then move into giving AI a memory, equipping agents with tools, creating custom tools, and finally, processes and hierarchies.
All right, kicking things off with Section 1, the agentic AI landscape and how modern frameworks compare.
What is absolutely fascinating here is the core philosophical difference between these modern frameworks. Take LangGraph, right? It gives you total access to those granular core mechanics, the really low-level controls, while still offering high-level features. It's incredibly robust, but yeah, it can get pretty complex. Crew AI, on the other hand, is heavily focused on making complex orchestration as easy as humanly possible. It leans entirely into high-level abstraction. So instead of wiring up basic connections all day, you get to just focus on actually building your agents.
And honestly, the best part about all this, it's just how ridiculously accessible this technology has become. Both of these frameworks are adopting the absolute latest standards, like the Model Context Protocol. But practically speaking, you don't need some massive, expensive supercomputer to build these teams. You can literally run Crew AI right inside a Google Colab notebook just by using the Nest Async Cryo library. Plus, you can run highly efficient tests using free-tier models like Google Gemini 1.5 Flash, along with Google's embedding configurations. I mean, you can basically build out enterprise-level AI crews for virtually zero cost while you're in the development phase.
Moving right along to Section 2, giving AI a memory, or basically building the brain for your AI crew.
Now, we've all been there. What happens when your AI just completely forgets what you told it 5 minutes ago? It's incredibly frustrating, and it's a massive limitation of basic LLMs. You give them this really rich, complex persona, you feed them all the crucial details about your project, and then, just a few prompts later, they've completely lost the plot. They simply can't track long-term context or handle multi-step projects without a proper memory system. They desperately need a persistent brain.
Well, Crew AI actually handles these distinct layers of memory totally automatically. It's kind of like human memory. Think of short-term memory as remembering today's tasks, right? It uses databases like ChromaDB or SQLite to track the immediate back-and-forth conversation. Long-term memory is more like recalling your childhood friends. It summarizes past projects and saves those finalized outputs to a local SQL database. It even has entity memory, which is specifically designed for tracking complex relationships between different people, places, and concepts.
And you're probably thinking, okay, this sounds great, but how hard is it to actually implement? It's astonishingly simple. You literally just toggle one single parameter in your crew configuration. By setting memory equals true, your crew instantly begins saving its history. It creates the local storage paths and lets your agents dynamically pull in historical context exactly when they need it. It genuinely mimics human recall.
Taking it even a step further, you can integrate third-party servers, like the Mem0 API, to handle user memory. This is huge because it means the AI can actually learn specific preferences tied to individual users. So, say John mentions that his absolute favorite vacation spot is the beach. The system securely logs that under his ID. The very next time John logs in and asks for a travel recommendation, the agents automatically retrieve that data. They give him a highly personalized, context-aware answer, and John never even had to repeat himself.
All right, Section 3, equipping agents with tools. We gave the AI a brain, now let's give it some hands.
So, an LLM on its own is basically trapped in a box. It only knows what existed in its training data up to a specific date. But what if you actually need it to check a live fluctuating stock price, or maybe see if a specific student has paid their fees today? Tools are the answer here. They allow the AI to finally break out of that box and actively reach out into the live, real world.
Fortunately for us, the framework comes completely loaded with these powerful, pre-built tools right out of the box, pulling from the Crew AI toolkit and LangChain.
For instance, you've got the SERPer tool for live internet searching and web scraping. You have file and directory tools so the AI can literally crawl through and analyze your local code bases. And there is even a code interpreter tool, which is just wild to think about. An AI teacher agent could actually use that interpreter to write Python code, execute it securely inside an isolated Docker container, test it, and then grade a student's submission based entirely on the output.
But honestly, the real magic here is the automation. You don't have to sit there and manually tell the AI exactly how to execute these tools. The agent is smart enough to autonomously figure out which tool to use just by reading your natural language prompt. It looks at your request, extracts the necessary data, maps it perfectly to the tool's parameters, and fires it off entirely on its own.
Which brings us nicely to Section 4, creating custom tools and building specialized functions.
Okay, so what if you want to connect the AI to your company's proprietary in-house database, something that obviously doesn't have a pre-built tool yet? Creating a custom tool is actually incredibly straightforward. It really just breaks down into 3 simple steps. First, you define exactly what inputs the tool needs. Second, you wrap it in the framework's architecture. And third, you just write the standard Python code that does the heavy lifting. Let's look at the 2 different ways you can pull this off.
The first way is method 1, which is class-based. This is absolutely ideal for highly structured inputs. For example, let's say you want your AI to generate an official student ID card. You'd build a custom class with a Pydantic schema, which is essentially just a very strict rulebook for the AI. This forces the AI to collect exactly what you need, like the student's name and their roll number, before it's even allowed to run the logic to generate the card. It's rigid, it's safe, and it's highly structured. On the flip side, we have method 2, which honestly feels like developer magic. For quick, simple operations, you just write a totally standard Python function. Say, a function that queries a feed dictionary. Then, you just slap a simple @tool decorator right on top of it. Boom. Suddenly, your AI agent can query your internal systems in real time, and it requires practically zero boilerplate code.
And that leads us to our final core concept. Section 5, processes and hierarchies. Or as I like to call it, giving the crew a boss. By default, AI crews run on what's called a sequential process, meaning Agent 1 does the research, hands it off to Agent 2 who writes the draft, who then hands it to Agent 3 who edits it. It's very predictable, much like a factory assembly line. But as you know, real-world, complex projects rarely work in a perfectly straight line like that, right? They require a hierarchical structure, where work is dynamically delegated on the fly based on the exact situation at hand.
And this is exactly where we introduce the manager agent. Think of the manager agent as your overarching, highly capable project manager. This is a specific LLM whose entire persona, its whole reason for being, is dedicated to evaluating the grand goal. It looks at the team of agents available, decides who is best suited for which subtask, and then rigorously verifies the final output to ensure absolute quality.
Setting this up is a breeze. You just update your crew configuration to process.hierarchical. Then you assign a really powerful model, maybe GPT-4 or Gemini 2.0, to act as the manager LLM. The crucial step here is ensuring that allow delegation equals true is turned on. And here is the most beautiful part of this whole setup. You completely stop hard-coding who does what. You literally just hand a raw list of tasks to the crew, and the manager organically orchestrates the entire distribution of work based on the unique skills of your agents.
Actually, scratch that. There's one more massive pro tip here. Let's look at this final configuration tweak that turns this into a totally unstoppable workflow. By setting planning equals true in your crew settings, you actually spawn this invisible planning agent. Before a single tool is ever touched or a single web search is made, this planning agent steps in and maps out a complete, highly efficient, step-by-step action plan for the whole team. It prevents wasted API calls, reduces hallucinations, and keeps the entire crew laser-focused on the goal.
So, stepping back, we have fundamentally moved away from those simple prompt and response bots. We are now talking about intelligent, memory-retaining, tool-wielding organizations that can completely manage themselves. With these components mastered, the possibilities are literally endless. Think about your daily repetitive tasks, or your really complex research needs, or those massive data processing pipelines. With everything you've learned today, what complex workflow are you going to automate next? Thanks so much for joining me on this explainer, and I absolutely cannot wait to see what you build.